Well, so welcome to my kitchen. Here's my best friend who keeps me going all day, the coffee maker. And, well, what we're going to do in the kitchen is see how well we can replicate what I showed you in the last video in the lab. Because I know you've got none of that stuff unless you are a bit obsessive about lab work, which I would absolutely welcome. So it's a density lab. So we have to measure mass, and we have to measure volume. And we're also asked to measure temperature. And if you're anything like me, to measure temperature, you've only got something like this. This is a meat thermometer. And the meat thermometer has a minimum temperature here that it shows, allegedly, of 120 degrees Fahrenheit. And that is, according to this, 49 degrees Celsius. And of course, we want Celsius. But we want it a lot lower than 49 degrees Celsius, which is like Death Valley on the hottest day ever. And so I'm going to use my lab assistant here to ask it a question. And hey Siri, what is the temperature right here, right now?
It's currently 18 degrees.
It's currently 18 degrees, she says in her Australian accent. And so, what I know is that where the needle is pointing right now is 18 degrees Celsius. And so what I can do now is use my extremely precise millimeter ruler to measure how far, and this is very rough, but how far 10 degrees Celsius is. And it is 12 millimeters. And so I measure 6 millimeters each side of where I measured 18, 6, and 6. And then what I've got is 18 in the middle, and 18 take 5 is 13, and 18 plus 5 is 23, and then I make the marks to indicate 5 gradations either side of that. So now I have a calibrated thermometer, which isn't very good, but it's the best I've got, and it's going to measure any temperature between 13 and 23 degrees, which I think is all I'm going to need. So that's awesome. Not the best thing in the world, but it's fairly awesome. Now what I'm going to do is, let's see, density is mass over volume. Now here's my mass measuring device, which is a little set of kitchen scales, and it doesn't measure to the nearest hundredth of a gram like the one in the lab. Well, the one in the lab was 1,000th of a gram, but the sheet asks for 100th of a gram. This measures to the nearest gram. Oh. So, what the lab sheet asks you to do is measure 10 milliliters and then find the mass of that. And measuring that mass, it's really not going to show me much in the way of difference. So what I'm going to have to do, because I'm 2 decimal places worse off with this device, I'm going to have to increase the volumes that I measure. And I'll show you what I mean when I do that. So, measuring volume now. So I've got these two things with volume measurements. I've got my little measuring jug here, and I've got this Ölçü bardak, a measuring glass that I brought from Turkey, and this one has a thinner diameter than this one. So it's going to be more precise. Because it's thinner, each milliliter will go further up the glass, therefore allowing the measurements to be a little further apart. And so I'm going to measure 100 milliliters. If I can find my 100 milliliters, there they are. Bottom of the meniscus. You're probably seeing my bald patch right now, sorry about that. So here it is. Now that's not much of a device. I need something narrower. Fortunately, my wife likes these as flower vases. This one's a bit dirty because I've been using it all afternoon to practice what I'm doing here, but this looks quite nice with a single red rose in it. But it's going to look even better for me as my measuring cylinder today. It's shaped like one, but it doesn't have the gradations on it. So what I do is this. I fill this up to 100 milliliters, and that's about all it takes. And then I use my faithful Sharpie to make a mark at the bottom of the meniscus, and that is 100 milliliters. And I can go even further with that because I get my handy millimeter ruler and I measure up to there, and that is 185 millimeters. So what I know now, I divide by 10, every 18.5 millimeters is 10 milliliters. So I've got, if I choose to make those marks there, and I'll do a couple of those now, but I can't work out some of the multiples. 37. Okay, so if I do this sort of thing, I should be measuring it better than that, but I can get a reasonably precise measuring cylinder if I take the time. But one, I don't think you've got one of these in your house. Two, I don't need to be so precise. So we've got these. Any of these will do. They've got parallel sides. If they've got parallel sides, they work. If they've got in and out sides, or they go slightly out, or there's some designer thing where they're shaped like a pyramid, avoid them. I can use this. I just bought this from Safeway. It's some hideously poisonous drink, and I just poured it out and took the label off so you can't see what it is. And so what I'm going to do is show you this part. Well, that's a hassle because that is not straight up or down. They're not parallel sides. They've got these dimples in the bottom. And so what this is not going to be good for is measuring volumes here. Here is fine. So here's what I do. I use my measuring cylinder here, or this, or whatever, and I pour in 100 milliliters. Awesome. Goody. And I put that on my balance, and I zero it. Because I don't care about that stuff. That 100 milliliters in the bottom, the only thing that's for is to eliminate that irregularity at the bottom. Now I'm going to pour 200 milliliters into here. Into this, by the way. I don't think you can see that. And good one. That's right at the bottom of the meniscus. This is now at 0. Let's see if I can find a funnel. Yes, I can. Here's my funnel. And I'll pour this into here. Still reading 0. No longer reading 0. Is now reading 202 grams. And I know that I added 200 milliliters of it. 202 divided by 200, that's a pretty easy measurement of density. So this sort of thing is just the stuff I found around the house. You can see I've managed to calibrate a thermometer, I've managed to calibrate a measuring cylinder, and I've managed to come up with a fairly rough sort of measuring cylinder that allows me to measure the mass of 200 grams. It's not what the question sheet asked you to do, but it's a way of working out the density. One final thing before I go about the graph that you're asked to draw. What I expect to see from a whole lot of you is one of those absolutely hideous little things that you do on Excel and ends up with these enormous dots and some ridiculous sort of best fit line approximation that you make. Don't do that. Hand draw the best fit line, and I'll show you why. So here's the graph I've drawn. I don't know how well you can see it. I'll move it out a bit. But you can see it's got a title, it's got 2 axes, and the axes are as big as possible. And they always tell you to do the axes as big as possible, and here's why. The best fit line is not linear. I repeat, it's not linear. When you first do it, it's going to look linear. When you try and get Excel to draw the best fit line, it's going to draw it as a straight line, but it isn't. Have a look here at the bottom. It's very definitely not a straight line there. It becomes more and more approximately straight as it goes up, as it increases the volume of sugar, the mass of sugar that's put in it. But I repeat, it's not a straight line. And you can only make that clear by drawing the best fit line by hand, like this. Okay? So, be aware of what's on this graph. This is not a pretty graph, but it's an acceptable graph. What Excel does, probably, I'm sorry to say, won't be. When you finish it, All I basically do is take a photo of it or use one of those scanning apps on my iPhone and then put the result into a Word file and then save it as a PDF. And that seems to make things small enough to transmit fairly quickly and easily. All right, good luck with this. Good luck in your kitchen and not in the lab. And I really, really wish that I was seeing you in the lab. But I'll see you on Teams.